In this class, we are going to discuss about the sign test. This is the first and the simplest test that is available in the non-parametric test. What is sign test? The sign test is a non-parametric test equivalent to t-test in the parametric case. In test test, we assume the normality and we take the mean as the location parameter. And but in saying that we only assume there is a continuity, no normality, so we cannot able to take mean as the location parameter to be tested. So in this case, we take the median as the location parameter to be tested. This is because median is that value we can clearly divide the all observation into two equal groups. In the case of distribution sense or distribution, we consider the curve of the distribution. The entire area under the curve is divided equally into two parts by the median. So if m is the median, we have probability of x less than or equal to m equal to probability of x greater than or m equal to m equal to 1 by 2. So there are, as in the case of parametric t-test, here also we have two problems. Usually comes in connection with testing of hypothesis. That is a one sample problem in which we test the hypothesis h m equal to h naught m equal to m naught, where m naught is some suggested or pre-specified value. And the second one is testing of equality of median of two populations are same or not. That is to test the hypothesis h naught m1 equal to m2. We consider them one by one. So the first one is one sample sign test for median. Well, our null hypothesis is h naught m equal to m naught, and we have the alternative one tailed or two tailed hypothesis as seen in the PowerPoint as h1 m less than m naught, h1 m greater than m naught, and h1 m naught equal to m naught. To test the hypothesis, we take a random sample x1, x2, etc. xm from the population. And the steps for the carrying out the test is first we calculate xi minus m naught for fi observation from x1 to x1. And then some of them may be negative, some of them may be positive depending on if xi less than m naught, then they take the negative values. If xi greater than m naught, they take the positive values, and some may be 0. When xi equal to m naught, then they will take the value 0. So first, as we already mentioned, find xi minus m naught. Then count the number of negative values. So only the number of negative values, not any dimension or magnitude of that. Only the numbers should be there counted. Similarly, now count the number of positive values. And we define n minus 1, n minus as the number of capital N minus as the number of negative values, and n plus as the number of positive values. And whenever 0 occurs, we discard them. And we say n, capital N, the total number of observations used for test is n plus and plus n minus. So that is the total number of non-zero values. If no 0 occurs, then capital N is equal to small n. Otherwise, it is n minus the number of zeros occurs. The test statistics is taken as n plus the number of positive signs, and this has a binomial distribution. So for critical region or the rejection region, or the decision should be taken in such a way that if the hypothesis is alternative hypothesis is h1 m less than m naught, that is the lower tail hypothesis, we reject H naught if the calculated T is less than or equal to T alpha, and if M greater than M naught, we reject H naught if T greater than or equal to T dash alpha. So this T alpha and T dash alpha values are obtained from the table. Again, if the alternative hypothesis is H naught, H1, M naught equal to M naught, for two tails, that is reject H naught if T less than or equal to T alpha A2 or T greater than or equal to T alpha A2. Or in other ways, if capital calculated T lies between T alpha by 2 and T alpha by T dash alpha by 2, we accept the hypothesis. That is, if a T value is greater than T alpha by 2 or less than T dash alpha by 2, we accept the hypothesis. Otherwise, we reject it. If a value takes a value, if T is equal to T alpha by 2 or if T equal to T dash alpha by 2, then also we reject the null hypothesis. Now I show you how we can find the T alpha by 2, T dash alpha by 2. So this is the table. You can see here, this is the table that we have used for testing the sign test median. So it is given capital N, the number of observations used for testing, that is N plus N minus, and here P value, instead of P value, alpha value, it is given here P value. So P value is equivalent to alpha value. And we have a left tail value, so some left tail values are given here and right tail values are given here. So for each N, we have a set of left tail values and a set of right tail values corresponding to the P value. These values are taken as T alpha by 2 or T alpha according to the value of alpha. As alpha is equivalent, again I repeat, equivalent to P. So if if N equal to 12 and we wanted to find alpha equal to 0.5, and here it is given only one thing you have to observe is that we cannot able to find exactly 0.5 in this way, 0.05 or 0.025. If you take alpha equal to 0.05 and alpha, then alpha by 2 is 0.025. So we cannot able to find exact 0.025. Sometimes there may be there, but so we approximate it. We take the value which is most close to 0.05. So here it is 0.7, this one 0.0730. So T alpha is 3 and T alpha by T dash alpha is 9. Thus left value is taken as T alpha and right value is taken as T dash alpha. So T alpha is 3 and T dash alpha is 9. And similarly, if you take wanted to find alpha by 2, so this is the p value very near to that alpha by 2, 0.025. So in this case, T dash alpha is 2, T alpha by 2 is 2, T dash alpha by 2 is 10. So this is the way which we have to find the stable value. So come to the example. So here we have values given and we wanted to test the hypothesis that the median value is 22. So let us see how we are going to calculate this value. So here it is xi, it is xi as to the extent. So that we can see how we can able to calculate the value. So I take this to the Excel sheet. So here I calculate this one, 9 minus 4 minus 22. So 9 minus 4 being negative value, so it should be negative. So similarly, I calculate the other values also. So I just find out the difference, and then I put this difference and take these differences to the PowerPoint. So I copy this and put here. So that I got this as my values, this selected portion, from which I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 negative values and only 5 positive values. So there is no zero, so we can have capital N equal to 20. Now we look into the table. So again, the alternative hypothesis is m less than 22. So we have to obtain a T alpha. So T alpha value corresponding to n equal to 20. So when you go right here, you can see that this is n equal to 20, and we have to obtain alpha value corresponding to 0.05. That is the left side value. So here it is 0.05, then n equal to 10, and you obtain 6 as your alpha, sorry, critical value, that is T alpha. So that is given here, T alpha is equal. Since T less than T alpha, as per that, we will get the hypothesis and conclude that n is less than 22. So here T is 5, which is less than 6. So we reject the hypothesis and conclude n is less than 22. So that's a one-page test. Here there is another test, which is an example in which we have to test the hypothesis h0 m equal to 30, again is h1 m not equal to 30. It is a two-page test. As in the early case, we take the differences, that is 31.5 minus 30, which is plus 30 plus 1.5. Similarly, 28.8 minus 30, which is negative 1.0, and it is calculated here. See that these three values are 30, so it comes 30 minus 8 is 0. So we discard these three values and we count the positive, and actually we want the positive number. We count the positive number. This is first one, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13. So we have 13 positive values, and since three values are directed and four negative values, so capital is 17. This is because three values are after 20 observations, three values become 0. So capital N is 70, and such that it is the number of positive value, which is 30. So if we take alpha equal to 3/0.5, we have to obtain two values, T alpha by 2 and T alpha by dash, T dash alpha by 2 from the table. Here it is given 40 and 30. Here just look whether it is true or not. So corresponding to 70, we wanted to check, and so it is given here 0.025. So equivalently you have 4, and here it is 30. So n equal to 70, T alpha by 2 equal to 4, and T dash alpha by 2 equal to 30. So you can easily calculate, count, observe from, or get it from the table. So that is given here. Since here T alpha by T is 13 and T alpha by 2 is 13, both are equal, so we reject h0 and conclude that m not equal to m naught. Okay. Likewise, there is a example here which tests the hypothesis h0 m equal to 150 greater than, and alternatively h1 m greater than 150. So You can easily go through that. The second test that remains in the or used in the median test is testing the equality of median of two population. So normally, instead of one difference that we have in usual one independent family t test, and here is that this is equivalent to paired t test. We take the two samples as observation as based on paired samples. So this test develops for paired samples, not for independent samples. That means both the x values and y values, the first both the population value n1 and n2 should be the same. So as usual, here the null hypothesis is put as x naught m1 equal to m2, and alternatives are m1 less than m2, m1 greater than m2, or m1 not equal to m2, the one tail and two tail hypothesis. So again, only the difference between the one sample and two sample is that in the one sample case, we find the difference of xi and the median, xi minus m naught. Instead of here, we calculate di, which is called xi minus yi. That is the difference of the first set of observation with what the second set of observation. That's the first population observation minus the second population observation. So here we, as usual, we count the number of positive DI and the negative DI, and take n minus as the number of negative DI and n plus as the number of positive DI. So it's the count number only, no magnitude is considered. And again we will start the number of zeros. So if m1 equal to xi equal to yi, then you get di should be 0. That values are discarded. Here also we take the same test statistic Tn plus as the number of positive sign, which is given as binomial distribution. So under the null hypothesis, it follows the binomial distribution. And the critical invariance remains same as in the early case if alternative hypothesis is m1 less than m2, t less than or equal to t alpha by 2, h1 m1 greater than m2, then we have t greater than or equal to t dash alpha. And for the two tail test, if the calculated t value is less than or equal to t alpha by 2 or greater than or equal to t dash alpha by 2, we reject the null hypothesis. So that is, if we accept the null hypothesis, if the value is greater than, strictly greater than t alpha by 2 or strictly less than t alpha by 2. So in between t alpha by 2 and t alpha by 2, if you get a t value, then you can accept the hypothesis. Otherwise, we reject the hypothesis. So these are only things that have difference between one sample and two samples. Again, I said, in one sample we find xi minus m naught, and here we find xi minus y. So here is a small example in which it is given. I'll take this. It is given as some treatment, and group number as 12 treatments are given, and xi and yi are also given. So I'll show you how we calculate whether what is d. So d is the difference between x minus y, xi minus y. So this is the d. So that is 3.5, and so this is equal to 3.5 minus 5.6. So if you get it is negative So likewise, you can calculate for all your variables, and so that you obtain this one table. Again, here you have 1, 2, 3, 4, 5, 6, 7, 8, 9 negative values, and 1, 2, 3 positive values. And altogether, there is no zero. Capital N have 12 values. And again, t plus is t equal to n plus is taken as the sample. So t equal to 3, and we can obtain the two values from the table. It is 12, and the alternative hypothesis is 2 tails. So we will see the table. So 12, n equal to 12 is given, and T alpha by 2 is 0.025. It's not that, but the equivalent value is 0.0193. So T alpha is 2, alpha by 2 is 2, and T alpha dash alpha by 2 is 10. So it is given T alpha by 2 is 2 and T dash alpha by 2 is 10. Since the value T is greater than 3 and less than 10, we accept H naught and conclude that the linear of two treatment matrix same. So now we consider the case where we have this n become very large. If n is less than or equal to 10, 20, we can use the this type of median test discussed so far and use the table given here, this table. So you can observe that only up to 20 the values is given. If n will become greater than 20, it is assumed that this follows normal distribution. So the number of positive signs follows normal distribution or Z distribution. It has mean mu equal to n by 2 and sigma equal to root of n by 2. And in this case, the statistics is taken as t minus n by 2 divided by t minus mu divided by sigma, or t minus n by 2 divided by root of n. It has standard normal distribution. The critical regions are lower tail rejected not if actual Z less than or equal to critical minus Z alpha. For upper tail rejected not if actual Z greater than or equal to critical Z alpha. And for two tail test, we take the calculated absolute value of Z is greater than Z alpha by 2. You know, minus Z alpha for a given, if alpha equal to 0.05, Z alpha is 1.645 and Z alpha by 2 is 1.96. So we use the normal table and the same critical value to be used from the Z table discussed in the parametric test. So as an example, here it is given 22 students pre-test and post-test values are given, and we wanted to test whether there is any difference or any improvement in there is an improvement in the test or the student performance. So the hypothesis is M1 equal to M naught, again is M1 less than M2. That is the second score is greater than first. So we find as usual the difference is 17 minus 16 equal to plus 1 for every 22 observation and count the positive sign. First one, second one, third one, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13. So n plus is obtained as n and n minus is 9 is there is no negative, so capital N is 22. So C is taken as 30. Now we calculate n is 22, so it is n by 2 is 11 and root n 22 by 2. So what you got is this value. So here the calculated Z value is 0.85 and the tabled value is minus 6.05. This 0.85 is a positive value and minus which is greater than minus 6.45. So we just take note and conclude that the training is not effect. So this much about the sign test. Thank you.